Okay, moving on with 6.2, we kind of took a look at the angles in standard position in quadrant 1. Well, now we're going to go all the way through the circle with all four quadrants. So when we take a look at the notes for 6.2, here's kind of our introductory ideas here. In quadrant 1, we have the initial side here and the terminal side there. Angle theta is in standard position when we're between 0 and 90 degrees. In quadrant 2, it's between 90 and 180 degrees. In quadrant 3, it's going to be between 180 and 270 degrees. And in quadrant 4, we're still measuring this way, it's going to be between 270 and 360 degrees. Now the reference for all four angles is the acute angle that the terminal arm makes with the x-axis. So that's whatever x-axis is closest to. So you want to make sure you know that you don't always have to measure from the positive aspect of the x-axis. You're just kind of looking at whichever x-axis is closer. So for this one, I'm just going to put in some lines here. So here's 35 degrees. So here's something with a reference angle, let's say 35. So we'll put this in here as 35 degrees, right? And in quadrant 1, we're referring it, 35 is the reference angle. It's actually the answer as well. So here's the y-axis, here's the x-axis, and here's the origin. Now, moving on to quadrant 2, when we have a reference angle of 35, what it means is we draw the angle in quadrant 2, but the 35 is going to be to this part of the x-axis here. So the 35, the reference angle is we're referring to 35 degrees off that part, right? So that means to calculate what the angle actually is we have 180 here minus 35 there. Means the actual angle is going to be 145 degrees. So we're just going to go over here and give the answer, measuring from the positive aspect of the x-axis counterclockwise to be 145 degrees. Okay, we're going to move down a little bit. I don't think I can adjust this here. Let's move down to the next couple of quadrants here. Maybe not that much. Okay, so now what happens in this quadrant is we're going to have still a reference angle of 35 degrees. So let's say that this comes off here. And we'll just stick a little 35 here as our reference, but it's 35 degrees in quadrant 3. And so we go all the way around here. And all this means is we have to add 180 degrees plus 35 degrees is equal to 215 degrees. So that's my answer here. And you've probably got this pattern by now. In quadrant 4, what happens is 35 degrees is coming measured from the closest x-axis available. So this is going to be 35 degrees here, and we're going to go all the way around the circle to calculate what it is. We know a full circle is 360 degrees, but we are indeed 35 degrees short. So that's going to give us 325 degrees. So this is 325. So that's how you use a reference angle to draw different values around the four quadrants. Now, in this one, the next idea that says here, the reference angle for any angle in standard position can be determined. For an angle in quadrant 2, such as 155, what's the reference angle? So this is like moving this, that's like backwards from the first one. So in this one, 155, we draw this angle in like so, and we just say that this is 155 degrees this way, 155 degrees. So the reference angle, one way you can do it is the longhand, right? Reference, this is the same for angle, is going to be equal to, full half circle is 180 degrees, but we have to subtract the 155, so that means our reference angle is going to be equal to 25 degrees. So that's here at 25 degrees. Quadrant 3, such as 325, what's the reference angle going to be? So 325, we'll sketch in like so, and again give a picture to illustrate what's going on here. But we have this, so all we have to do is, this is 180, that's 235. Another way we can do reference angle is that is 235 degrees minus 180 degrees is going to give us 55 degrees. So this is 235 little angle in here is going to be equal to 55 degrees. And an angle in quadrant 4, if we the angle is 310 degrees, then we're going to take a look at what that reference angle is going to be. So if we sketch it in something like that, and bring it all the way around here, and this is 310 degrees. A full circle would be 360. So this is 360 degrees minus 310 degrees, means that our reference angle is going to be 50 degrees. So that'll just be in here. Okay, so that's how you go around the circle. What about the ratios of this in standard position? Well, sometimes it's easiest to understand if we just draw it out for you here. And I'll see if I can make this fit. Okay, so in quadrant 1, what happens is we've got a few diagrams, and in this what we're going to do is figure out where they're positive and where they're negative. Okay, so let me just put these lines in here first of all. So there's quadrant 1, there's a line quadrant 2, there's 1 and 3. No, that's not going to work. I'll just do these two first. Rats. Drop a perpendicular here until it hits the x-axis. Make a 90-degree triangle. This is theta here. We know that this r value is always equal to 1 because it's in standard position. We know that the distance along here, this point here, is going to be positive x, positive y. We know that this is going to be a distance of positive x, and that's going to be a distance of positive y. So cos theta is equal to the adjacent divided by hypotenuse, so that's x divided by r. Sine theta is going to be the opposite, which is y, divided by hypotenuse, which is r, and tan theta is just going to be y divided by x. Now, what you'll notice here is that it's positive divided by positive, positive divided by positive, and positive divided by positive. And what that means in this quadrant is that all the ratios are positive. Okay, so we'll just circle the ones that are positive. Over here, we get a bit of a change. In quadrant 2, what happens is we get the r value is always positive because it's a distance. We see this y value is positive because it's above the x-axis, but this movement here means that this value is going to be a negative x. Okay, and our theta value is going to be measured down here. So in our cos theta, it's going to be equal to negative x over r. In our sine theta, it's going to be equal to positive y over r. And then in our tan theta, it's going to be equal to y over negative x. So that means that the only positive one in quadrant 2 is going to be the sine. Okay. Let's move down here. I should have got more of a page in there, that would have been better. But we'll focus on these guys for now. So in quadrant 3, same sort of deal here. We'll drop a perpendicular. But you notice that both the x and the y are negative. So here we have an r, here's a negative x value, and here's my negative y value. So we've got cos theta is equal to negative x divided by r. Sine theta is going to be equal to negative y divided by r, which would be a negative ratio. Tan theta is going to be equal to negative y divided by negative x, and negative divided by negative is a positive. So in quadrant 3, what happens is that tangent is the only one that's positive here. And lastly, in quadrant 4, we know that our x value is positive and our y value is negative. So we create our line and drop the perpendicular to the x-axis. The x is positive, the y is negative. Here's our measure of theta, and here's our r. So cos theta is going to be equal to x divided by r. Sine theta is going to be equal to negative y divided by r, and tan theta, tan theta is going to be equal to negative y divided by x. So the only one that's positive here is going to be our cosine. Okay. Now if we were to quickly give you a little memory device to tell you which trigonometric ratio is positive in which quadrant, it would look something like this. Let's really thicken this up and use a really nice color. Cosine is positive in quadrant 4. All are positive in quadrant 1. Sine is positive in quadrant 2. And tangent is positive in quadrant 3. CAST gives you a little device to tell you which is positive in which quadrant.